In this video, we're going to take a look at what you can do when your pattern is not linear. So everything we know only applies to linear models. We know that we want to have a scatter plot that looks linear. We know that we want to look at the residual plot and not see any leftover pattern. We know we want the R value to be as close as possible to +1 or -1. We want R squared as close to 100% as possible. And we want our standard deviation of the residuals as close to 0 as possible. So all of those things that we know how to do only work for linear models. So if we have something like this, where here we see this clear pattern where if you think about your function families from back in Algebra 2, this clearly looks exponential. And our rules and things that we know for linear are not going to apply here. So what we have to do is something called straightening the curve. So you're going to take what you remember from your function families in Algebra 2 and about inverses and apply those things. So inverses, remember, those are things that undo each other. So the opposite of squaring is square rooting. The opposite of an exponential is a logarithm. So because this appears to be exponential, I know that I'm going to need to use a logarithm to straighten the data. The problem is there is some guess and check here. I don't know if I should take the log of the x's or the y's or of both. So what you'll do is you'll put the original data in your calculator into like list 1 and list 2, and then in list 3 you'll store the natural log of your x list, and in list 4 you'll store the natural log of your y list. Now it really doesn't matter if you use natural log or common log, either one's going to work fine. The work along the way will be different, but then your final answers will still be the same. So what you'll do, again, you'll store these values into your calculator. So here we've got, these would have been our x's, and then this would have been the natural log of our y's that we probably maybe stored in list 4 possibly. And then here we've got our natural log of our x's, which we probably stored in list 3. And this is the same thing again. This is our natural log of our y's from list 4. And you're just kind of guessing and checking, and you're making scatter plots. And then you're looking for them to now become normal, or to become linear. So this second one here is the clear winner in that it becomes a line. This one still shows some curvature. So next up, you would, if you were using your calculator, run a linear regression on your list 3 and your list 4. And you would look for the information to get your least squared regression line. Now, in reality, a lot of times you're just going to be given this computer output, and then you're going to interpret it. You won't have a ton of time to be typing all of these things into your calculator on the AP exam. So we're just looking at this output and coming up with our conclusions. So we can pull from this computer output, we can pull out our slope and our y-intercept, and then plug those into our general least squared regression form. Our y hat equals a plus bx, except for now, remember, it's not really our x's and our y's, it's the natural log of our x's and the natural log of our y's. Again, you could have gotten this from your calculator as well if you did a least squared regression on your list 3 and list 4. So now that you've got this equation that results in a linear model, you can use this to make some predictions. So we want to predict what would happen if we had an AU of 102.15, so we're going to plug that in for our x value. And then we're going to use our calculator to find the natural log of the 102.15, multiply it by the 1.49986, add it to the 0.0002544, and that's going to give us the 6.939. So that's just coming right from typing that in your calculator. And then remember that the inverse of a natural log is your e as a base. If you were using common log, you'd be using 10 as a base. And you're applying those inverse operations to both sides of the equation to come up with your solution. Now again, there's a lot of guess and check and it can be a little frustrating. So here's a little chart that might help you get started in terms of your guessing and checking. So if you type your original data in for X and Y and you go to the scatter plot and it looks linear, that's great. Run with it and do what we've done before. Check your residual plot, check your standard deviation of your residuals and your coefficient of determination, and move on with making your predictions and using your equations. However, if you make that original plot and it looks like a power function, so that means maybe it looks like x squared, like a parabola, or x cubed, or x to the fourth. So if it looks something like that, your best bet, the first thing you should try is take either the natural log or the common log of your x's and store that in list 3, and your y, store that in list 4, and then run the whole regression and look at your scatter plot and your residual plot, etc., on your list 3 versus list 4. And then if your information looks exponential, just try running the x's, keep the x's, versus the log of the y's. And again, there's definitely a lot of trial and error, so you're going to run each of these, store them all in the different lists so that you're just changing the list number when you go to make your scatter plot, your residual plot, and then running your regression and looking at the standard deviation of the residuals and your coefficient of determination. So what you want to do, try all of these, and then here's what you're looking for. So first you're going to check your scatter plot, and you want it to look linear. If you have more than one of the tries that you made that look linear, then you're going to move on and check the residual plots. So then you're going to look to see which of the two residual plots looks like it's more randomly scattered with no pattern. If you have kind of like a tie there and you're still moving on, then next you would run your regressions and you would look at the standard deviation of the residuals, the correlation coefficient, and the coefficient of determination. And you'd want your standard deviation of the residuals to be as close as possible to 0. You want your R value to be as close as possible to either +1 or -1. And you want your R squared value to be as close as possible to 100%. So that third one, you kind of go down the list, 1, 2, 3. And you're looking for the ones that are closest to these values, kind of as a tiebreaker once you check items 1 and 2. Now again, for the most part, you're going to be given some scatter plots, and you're going to be told to look at and say, well, which one appears the most linear? Which one has the least pattern in the residuals? Which one has computer output that looks the best? And then you're just going to be choosing the best one from a list of several options. You should also be able to take that new model and then plug in a value for x and solve for y, or plug in a value for y and solve for x. So you need to know things like the inverse of squaring is square rooting. The inverse of an exponential is a log. So you'll do those sorts of things that you did in Algebra 2 to be able to solve for an x or solve for a y. There is a video to help you out with using your calculator and how to store these things in your lists. So make sure you try that first before moving on to the practice problems.